am Jananya from Department of ECE. Today's my topic on transmission lines types and parameters. Transmission lines. Introduction to transmission lines. Transmission lines are critical components for efficient power and signal delivery. Understanding their types and electrical parameters helps in designing reliable systems with minimal losses and distortion. This presentation covers the main types of transmission lines and key electrical characteristics essential for their analysis and applications. Transmission lines types. Overhead lines. Overhead lines are widely used in power transmission. Due to their cost effectiveness and ease of maintenance, these lines are supported by towers or poles and are exposed to environmental conditions. Their performance depends on conductor material, height and spacing with influence losses and induction. Underground cables. Underground cables offer protection from weather and reduced visual impact. They are insulated and viewed ground, making them suitable for urban areas. However, they typically have higher installation and maintenance costs and different thermal characteristics affecting current capacity. Coaxial lines. Coaxial lines are specialized transmission lines with a central conductor surrounded by an insulating layer and a metallic shield. They provide excellent shielding from electromagnetic interference and are commonly used for communication signals and high frequency applications. Electrical parameters. Resistance and reactance. Resistance in a transmission line causes power loss due to heat, while reactance is related to the line's inductance and capacitance, impacting voltage and current phases shifts. Both parameters depend on conductor material, frequency and physical configuration. Capacitance and inductance. Capacitance arises between conductors and affects voltage distribution, while inductance is linked to managed magnetic field generated by current flow. Together, they determine the line's ability to store and transfer energy, influencing signal delay and impedance characteristics. Characteristic impedance. Characteristic impedance is a fundamental property representing the ratio of voltage to current in transmission lines under steady state conditions. It depends on the line's inductance and capacitance per unit length. Maintaining impedance matching minimizes reflections and maximizes power transfer, which is essential in both power and communication systems. Transmission line modeling. Lumped versus distributed models. Lumped models simplify transmission lines by assuming parameters are concentrated at discrete points. They are useful for short lines. Distributed models represent parameters continuously along the line length, providing accurate analysis for longer lines and high frequency signals, capturing wave propagation effects precisely. Equivalent circuits. Equivalent circuits use combination of resistors, inductors and capacitors to simulate transmission line behavior. These models helps analyze signal flow, losses and impedance characteristics, enabling easier calculation and design optimizations for different line lengths and frequencies. Transmission line equations. Transmission line equation describe the voltage and current variations along the line using differential equations. These equations account for the effect of resistance, inductance, capacitance, and conductance, enabling prediction of wave propagation, reflection, and attenuation in complex line systems. Performance and applications. Signal attenuation and distortion. Attenuation refers to signal power loss as it travels along the line, mainly due to resistance and dielectric losses. Distortion occurs when different frequency components propagate at different speeds, degrading signal quality. Managing these factors is critical for maintaining integrity over long distance. Power handling capacity. Power handling capacity is the maximum power of transmission line can carry without overheating or breakdown. Depends on conductor size, material, cooling, and line design, impacting both safety and efficiency in power distribution networks and communication infrastructure. Applications in communication and power system. Transmission lines are fundamental in transmitting electrical power and communication signals. In power systems, they link generation to consumption centers, while in communication, they carry high frequency signals with minimal loss and interference, enabling technologies such as broadband internet and broadcasting. Conclusion. Understanding transmission line types and electrical parameters is essential for efficient system design and operation. Proper modeling, impedance matching, and managing attenuation optimize performance in power and communication applications. This knowledge supports reliable signal integrity, safety, and effective power delivery in diverse engineering field. Thank you.